Hello everyone. So ladies and gentlemen, dear colleagues and friends, good morning, good afternoon, and good evening. On behalf of the World Federation of Engineering Organizations, I warmly welcome you to join this webinar as a side event at the High-Level Political Forum 2020. The theme of this year's high-level political forum is accelerated action and transformative pathways, realizing the decades of action and delivery for sustainable development. Our webinar will discuss how the lever of science and technology can be used in peri-urban and urban development to advance the global sustainable development as a whole, and the case of implementing geospatial engineering. So we're going to start our webinar, and please, for every participants to open your chat box, and there's a link of a Google document. Please open that link and you can write down your questions that will be answered later by the panelists. And because the time is very limited, we will not allow oral question, but only the question write down in this link, or you can also use the Q&A button. So now let's start our webinar. First, please allow me invite Mr. He Fuxiang, Scientific Counselor of the Chinese Permanent Mission to United Nations. Mr. He, please give your address.
Honorable Professor Gong, President of World Federation of Engineering Organization. Distinguished guests, ladies and gentlemen, good morning, good afternoon, and good evening. It's a privilege to be invited to attend the High-Level Political Forum 2020 side event convened by the World Federation of Engineering Organizations. On behalf of the Chinese mission to the United Nations, I would like to take this opportunity to congratulate World Federation of Engineering Organizations for convening this very important event and exchange with you some ideas on the important role engineering technology plays in advancing sustainable development. First, engineering technology is an important engine for advancing the 2030 Agenda for Sustainable Development. As Chinese President Xi Jinping points out, engineering technology is a key driver triggering deep social revolution, benefiting human beings, transforming the future. In a word, engineering technology is an important driver behind the transformation of the world. In 2015, at the 70th anniversary of the United Nations, leaders of more than 190 member states joined recognize the 2030 Agenda for Sustainable Development. Over the past 5 years, although many achievements has been made, there are still huge challenges to meet the ultimate goals and the targets. Against this backdrop, at the Sustainable Development Summit in September last year, a Decade of Action Declaration was adopted to accelerate the realization of sustainable development goals in the coming decades, in which the need to better harness science, technology, and innovation as one of the 4 key levers was highlighted. In the era of the COVID-19 pandemic, it's more imperative for countries around the world to leverage science, technology, and innovation to accelerate global transformation and wants sustainable development goals. The role of engineering technology and engineers is of great importance. Second, leverage science, technology, and innovation to promote sustainable urban development is pivotal for advancing the sustainable development goals and targets. Since the Industrial Revolution, more and more people have moved to cities and metropolis. The 21st century will witness further urbanization. It's estimated that by 2050, cities will be home to 68% of world's population, consuming 66% of world's energy, and emitting 75% of world's total carbon dioxide. However, the increasing problem of imbalanced development within the cities and the gap between the urban and the peri-urban environment has become more compelling. The world has a large number of poor people living in the cities. Issues like water pollution, shortage of energy, and inadequate public health resources are some of the urgent challenges facing our cities. Therefore, sustainable urban development is crucial to achieving a future of sustainable development. This side event, convened by World Federation of Engineering Organizations, highlights these critical issues, provides the technical solution of integrating geospatial technology into building information models, which will present successful cases of application. We appreciate this effort by World Federation of Engineering Organizations and its partners. Third, thanks to the contribution of STI, great achievement has been made in the area of urbanization since China's opening up. Over the past 4 decades of China's reform and opening up, China has been dramatically urbanized, with the rate of urbanization increasing from less than 18% in the year 1978 to 36% in the year 2000, and exceeding 60% in the year 2019. The urban population has increased from less than 180 million in 1978 to 840 million in 2019. In this process, China attached great importance to sustainable development of cities by securing universal employment, implementing affordable housing projects, continuously improving infrastructure and their ability to withstand disasters, and promoting equal public health services, including compulsory education, medical care, and pensions for the seniors, etc., during which engineering technology has played an important role. In response to the new technology and the industrial revolution, the Chinese government is stepping up efforts in constructing new infrastructure characterized by digitalization, which will provide a strong impetus for accelerating sustainable development. We look forward to deepening international collaboration in engineering technology and urbanization, and work with the rest of the international community to accelerate sustainable development at city, country, and global levels. The pandemic of COVID-19 unravels the indisputable fact that all human beings live in a community of a shared future. People must unite to respond to the challenges collectively and work together to accelerate the attainment of sustainable development goals and targets. China will continue to pursue innovative, coordinated, green, open, and shared development, deeply engaging international collaboration on development and science, technology, and innovation, and reinforce global development partnership. to contribute even more to the implementation of the 2030 agenda for sustainable development. Thank you very much. Thank you.
Thank you, Professor Councillor He, for your kind speech, especially for your stress the importance of engineering technology and engineers for sustainable development. Now let's invite the first keynote speaker, Mr. Sanjay Kumar, who is the CEO of the World Geospatial Industry Council. Please, Sanjay.
Thank you very much. Very good morning, good afternoon, good evening to colleagues around the world. First of all, I would like to thank
Sanjay.
Yes.
Sanjay, please share your screen. Okay.
Can you see this?
Yes.
Wonderful. So thank you very much for the opportunity to participate in this very important event as part of the United Nations High-Level Political Forum, which has a theme of accelerating action and transformative pathways, and which is very timely because we live in consistent transformation mode. And in that consistent transformation mode, we have to make decisions very quickly and accelerate our process of decision making. And the topic which we have chosen is about resilient infrastructure is equally important because resilient infrastructure is something which is directly linked with sustainability. And sustainability is a term which is finding its real value in the given context, and the United Nations leadership in setting and defining the sustainable development goals is highly commendable. So moving forward, I think I would like to acknowledge and credit World Federation of Engineering Organizations for their very proactive support and participation in putting together a joint white paper. This white paper talks about the value of integrated geospatial and building information modeling solutions to advance the UN Sustainable Development Goals, wherein we are trying to put together a collaborative value of the engineering discipline as well as the geospatial discipline in addressing the resilient infrastructure challenges. And I'm very happy and delighted to announce that we shall be releasing this document today as now, and this document is available for public reading on WFEO and WGIC websites, which the Secretariat will inform you very soon. I would like to throw certain highlights about this report and why it is so important. So, as per the World Bank, the 70% of the world's infrastructure requirement until 2050 is yet to be built. And the remaining 30% of the world's infrastructure requirement until 2050 needs to be rebuilt. And that's the kind of infrastructure which we need in next 3 decades. And in this period of time, if we start addressing the value of resilient infrastructure, we will do a great service to our sustainability goal, because if we build an infrastructure which is able to cope up with disruptions and challenges, then we are actually saving a lot in terms of human lives and as well as livelihood. And I'll just share a couple of my thoughts on this topic. Resilient infrastructure is nothing but an ability of an infrastructure to resist, absorb, accommodate, and recover from any kind of disruption. That disruption could be man-made or could be natural. And that is the kind of importance that resilient infrastructure as a concept brings together, because when we have to make something for next 30 or 40 or 50 years, then we need to actually do the analysis of what is going to be the challenge in next 4 decades or 3 decades. So let's look at what causes the disruption into the infrastructure. Of course, natural shocks, which could be various kinds of disasters, be it flood or earthquake or cyclone. But at the same time, as the Chinese mission talked about, the growing urbanization and the pressure on the urban infrastructure is also causing a lot of disruption. And that kind of disruption is leading to a challenge of, or posing a serious challenge to the infrastructure. And how that challenge of infrastructure is having an impact. The impact is almost to the $18 billion cost or damage to the power and transport infrastructure in a year. This is a yearly fact, and almost $300 billion cost to the household and firms, and almost $90 billion cost to the welfare housing. So that's the kind of almost $450 billion of losses which we're talking about in terms of the infrastructure in a year. And that is why it is very important to make infrastructure which is more resilient. And if we invest into resilient infrastructure over a period of next 30 to 40 years, $1 of investment will bring almost $4 of saving to us. And what could be more sustainable than this, where you are saving that much of resources and that much of lives. And this is very important for the developing countries who are going to build more and more infrastructure. They are the ones who are investing into new infrastructure. And when they make that infrastructure today, and if it has much longer life, then it is going to be more beneficial towards their development. And that is powered by 4IR technology. We are living in fourth industrial revolution. And this fourth industrial revolution is nothing but it's a combination of three things. One is the sensors. We have a host of sensors around us that is collecting information. And second is the big data and artificial intelligence, because that is what is giving us an option to process humongous data from every side. And third is the telecom capability, which allows you to connect the whole workflow of an engineer from the site to the design to the design room or the construction sites. So you have three technologies of the 4IR, which is empowering you to basically collect, process, analyze, model the data. And that data is not only about today, but is based on the data of last 30, 40, 50 years. And then based on that, you start making a modeling of what kind of disruptions are likely to come in next 3 decades or 4 decades. And then accordingly, you build your resilient infrastructure. If you know that flood or earthquake or cyclone are going to hit, that is how you start preparing your buildings and infrastructure. GEOBIM solutions for resilient infrastructure is a classic example of collaboration of engineering discipline and geographical discipline. One which provides the machines and engineering tools, second which gives you a kind of a spatial dimension which connects and contextualizes the project with the human beings. It actually connects, models and helps you to understand the habitat area. It helps you to understand the topography. It helps you to understand topology, as well as it helps you to understand the likely human behavior. And that is where the convergence of geospatial and building information technologies are going to help you address the entirety of the cycle of the construction, right from planning to design to construction to maintenance. And that's the kind of comprehensivity this collaboration brings together in front of you. I'm just sharing 2-3 case studies, and before I conclude, one is talking about city resilience from natural disasters, which is talking about a goal 9 and goal 11 of SDGs, wherein enterprise level of GIS has been basically applied, and which brings hundreds and hundreds kind of different data sets and allows a centralized processing capability for the entire city, so that you're using the same database for addressing your your planning and creating a green city where you're planting a lot of trees, you are creating drainage system, you're creating the whole environment around in a smart city, and you have a enterprise information system powered by BIM and GIS. Second is, I wanted to share about, which is very impactful. This one actually is very close to my heart because it talks about, a very developing country, and it talks about the earthquake. We all know about Nepal as a country which has been very, kind of prone to various earthquakes. But under a partnership with the company, the Nepal government is developing a resilient building code. It's not just about recovery of the earthquake, but it's also about future, that how you are creating a building bylaws and codes which will be able to help the construction companies and the household owners to build their resilient houses. And household is something which is very important. You could have seen that in the kind of impact household has is about $300 billion losses, whereas the transport infrastructure is only about 18 to $20 billion losses. So household is a critical thing, and that is connected with the human beings directly. Third is a climate change. It is about a Faroe Island, which is the soil is very muddy, and it's very difficult, terrain. So we are using a lot of machine control technologies with all the excavators, and where you are actually using a very precise monitoring system to understand the, or to design the resilient infrastructure. So if you are able to do that, you are actually creating an infrastructure which is resilient to the environmental hostility. And if it is stable, it is going to be sustainable for longer. And that's the kind of value which we bring together as a combination of Geo and BIM technologies. I think this is my last slide. The way forward I would look to see is that we have to build some kind of governance models. We have to develop some kind of code of conduct, ethics, as well as the bylaws, which will kind of guidelines for the construction companies that how to use geospatial and BIM technologies. We have to create more and more standards around the innovations and data, so that the different kinds of disciplines of data can collaborate and work together. We have to build partnerships, and one of that partnership is World Federation of Engineering Organizations, as well as WGIC and UNGGIM. These three organizations have come together to create this joint white paper, which is a kind of example of partnership. And fourth is that we have to educate the financial investment leaders, that if they invest into technology adoption, then we are going to have longevity and better returns for them. With this, I would like to thank once again to each one of you, and would like to request you all to go through and download this document and give your suggestions to us so that we can improve it further. Thank you very much.
Thank you, Sanjay, for your speech, and especially for your announce the joint white paper, so which is for free download from the website of WFEO and the WGIC. Now let's invite Mr. Gregory Scott, who is the Secretariat from Secretariat UN Committee of Experts on Global Geospatial Information Management. Greg, the floor is yours.
Thank you. Welcome, colleagues. Good morning, good afternoon, good evening from around the world. And I'm hoping you can see my presentation on the screen now. Can you see that?
Yes.
Yes, thank you. I would like to just build on some of the introductory remarks that have been made, and what Sanjay also mentioned in terms of capability, and focus in particularly on the elements of the geospatial digital divide, and how we can think about what does that mean. The preamble of this white paper that's been put together with WFEO and also WGIC has inherently considered achieving the 2030 agenda is the need to bridge this geospatial digital divide. Sanjay, in his final slide, had a reference to this and how it builds capacity for using geospatial technology to enhance government decision-making processes and to undertake practices to achieve a digital transformation. I'd like to build on that some more, and in recognition that for countries to achieve the 2030 agenda, to develop a robust national geospatial data ecosystem and the associated geospatial frameworks, many countries, and developing countries in particular, will need to somehow bridge this divide. The question is, for many, is what is that geospatial digital divide? It's been used a lot now, but not a lot of discussion around what that looks like, what it means, and how we overcome it in a very innovative and transformative world. So what I would like to do is touch on some of these elements. On one hand, and Sanjay has mentioned a couple of these technology innovations, and I'm sure my colleagues in the presentations this morning will build on these a lot more. But in this world of artificial intelligence, the fourth industrial revolution, where we see augmented reality, we see BIM and LiDAR and other technologies, machine learning, and just infrastructure development with technology growing at a rapid pace. And this is very much so too in the geospatial and geomatics engineering, where technology and data are fused and harmonized together to enable us to make much better decisions, both in the entire process of infrastructure development, design, through to build, implementation, and management. So it's providing us with many, many opportunities. But at the same time, there's many parts of the world where such technologies and opportunities, and particularly access, is impeded. It is very, very limited. It's growing, that's for sure, but there's a lot of impediments to this opportunity and access. And I'll use those two words a number of times for developing countries. It is about providing opportunity and access, whether it be technology, data, capabilities, etc. The 2030 agenda very much recognizes this concept of the digital divide. And many of the other developing agendas, including the Sendai framework, touch on these elements, the potential, the great potential of information and communications technology, the global interconnectedness that we have, and human progress being accelerated by bridging this divide, developing knowledge societies, and scientific and technical innovation. But when we think about geospatial geomatics engineering, there's actually a more complicated process here, is that when we look at the data, big data, and other sources of information for bridging this divide, for engineering and geospatial technologies, there's a greater need for a more broader and defined transformation that is able to bridge not only the digital divide, but in particularly, as we in the UN have called this, the bridging of the geospatial digital divide. Let me just touch on I guess, elements of the digital divide that are well known now in the literatures. In essence, they are three components. One, obviously, is what I have termed here as the access gap. Is just having access to the internet and computers and ICT in general. But then that scales out into how do we then adopt with opportunity, with skills, with literacy and knowledge to do so. And then once we have those, how do we add value, digital value, with the use of technology and content, and doing that in a way where it's inclusive, where we have geographic inclusiveness. For example, there's a great difference between rural and urban capabilities in just getting access to the internet, or even in many developing countries, access to reliable electricity. But if we then think about those very basic requirements and we think about bridging the geospatial digital divide, it becomes a lot more complex. because now what we're talking about is all of this data ecosystem itself, whether it be engineering data, geospatial, and other emerging data sources, but particularly, as we term it now, a lot of this very big data that's becoming available. And then we apply that data with technology, as I have just mentioned, whether it be the Internet of Things, cloud computing, machine learning, but especially the modeling and analytics that go with this. So a key point here is that while data is not technology, technology is not data, but the two now are very, very tightly coupled. How do you leverage data without the use of solutions and technology? And how do you derive value in decision-making in this? And wrapping that around in the final circle there is this, what I've termed the geospatial policy gap. And this is around the need for countries, and particularly developing countries, to have access to frameworks and methodologies and guides that are interoperable, that are standards-based, that have the ability for countries to make change, to transform, and to ensure that they are not being left behind. And so this has been a big body of work in UN GGIM over the last 1 to 2 years, is about these frameworks. And I'll just touch on those just for a few minutes as I get towards the end of my presentation. And I want you to also consider that even though these frameworks that I'm talking about here in a geospatial context, they also apply across the broader industry and also engineering. And this is why we in UN GGIM are very excited to be able to be working with the World Federation of Engineering Organizations and the WGIC, the Geospatial Industry Council, because they broaden our capability. They enable us to think about this framework, as we call the IGIF, the Integrated Geospatial Information Framework, that has been developed for and by member states around the world. It provides a basis and guide for developing, integrating, and strengthening geospatial information management for countries. But in that, it's about having a mechanism to demonstrate leadership, cultivating champions, and building capacity for countries to take positive steps. There's a link there to our website, which has the framework, the IGIF, in detail for you to go and download. I will not discuss it in detail here. But in my concluding slide, I will reference a key part of this IGIF, and that's the 9 strategic pathways, which you can see on the left side of this presentation as parts of a jigsaw puzzle. And as Sanjay had in one of his slides, he talked about the way forward. And in that, he talked about governance and innovation and financial and partnerships, etc. Those processes are developed from these 9 strategic pathways. And they are about enabling countries to make change. And you will see in those pathways, there are a couple of key elements that I'll conclude with. The first 3 across the top, governance and institutions, policy and legal, and financial, are very much about the governance side of geospatial information management and the strengthening of it. The bottom 3, partnerships, capacity and education, communication and engagement, are about the people side. We need to be able to engage with our communities across all regions and all sectors. And through the middle 3, the data, innovation, and standards are really our comfort zone when we talk about data and technology. And they are really the glue that bring the governance and the institutions and the legal aspects together with the people and the human needs. Importantly, innovation is the center piece of these 9 strategic pathways. Innovation is the game changer. All of those strategic pathways can make progressive change towards the implementation of the 2030 agenda, towards the implementation of the SDGs, but it is the innovation, the ability to create and innovate and make substantial leapfrogs and change is where that change will happen very quickly, especially for developing countries, if we are able to bridge that geospatial digital divide. An important element of the IGIF is that it is inherently developed to do just that, to develop and strengthen arrangements in countries, to bridge the geospatial digital divide, to secure socioeconomic prosperity, and to ensure that we do not leave anyone behind as we go through this digital transformation, as we try to leverage more and more data around the world, but in a way where we can be doing it all together and inclusively. Thank you. I will cease my presentation there, and I wish you all for a good panel session this morning. Thank you.
Thank you. Thank you. Thank you, Greg. Thank you for introduce the framework of integrated geospatial information. And now let's welcome today's female speaker, Dr. Marlene Kanga. She's the immediate president, past president of WFEO and the leader of the project for WFEO on the publication of the white paper. Marlene, the floor is yours. You're muted, Marlene. Marlene, open your microphone.
Can you hear me now?
Yes.
Good evening.
Yes, it's okay. Yeah.
Good evening, good afternoon, and good morning from Sydney, Australia. It's a real pleasure to be here today to talk about the implementation of geospatial technologies for sustainable and smart cities as part of the high-level political forum being held at the United Nations in New York. As some of you might know, the World Federation of Engineering Organizations is the peak body for professional engineering institutions around the world. We have members in some 100 nations representing more than 30 million engineers. Many of these countries are in the developing world. The World Federation has a particular strategic objective and goal to advance the UN Sustainable Goals through engineering. And it recognizes the importance of building capacity using engineering and technology for sustainable development. And the topic today on the use of geospatial engineering and the roadmap in the report that is being launched today has that very objective to build capacity for implementing this advanced technology. And this aligns very much with what the previous speakers have said, the importance of this advanced technology and the need to build capacity to leave no one behind. I'm particularly delighted to be here because this project was initiated in 2019 when I was president of the Federation. And it had a very strategic objective, as has already been mentioned, in that it brought advanced technology and important partners like the WGIC and the UNGGIM to build capacity and to show how it can be done with practical case studies. And it also looks to the framework developed by the UNGGM, which Greg Scott has just spoken about, in terms of how it can be implemented and the way forward. This project also aligns with many other initiatives at the United Nations, in particular the UN Global Sustainable Development Report that was launched in September 2019, and also the UN Department of Economic and Social Affairs roadmaps for the implementation of science, technology, and innovation. Now, the UN Global Sustainable Development Report identified science and engineering as one of 4 levers to accelerate sustainable development. and urban and peri-urban environments as one of 6 pathways to accelerate this. And at this intersect of the 6 pathways and 4 levers, you have cities. And the goal here is to make cities smarter and more sustainable as part of the transformation for sustainable development. So the key messages for sustainable cities from the Global Sustainable Development Report are that cities are central to achieving all the 17 goals, because by 2015, cities will contain approximately 70% of the world's population and produce 85% of global economic output. And so there's an imperative for well-planned, integrated, and inclusive technology to prioritize access to jobs, housing, healthcare, and education for the well-being of the citizens of those cities, and to promote sustainable consumption and consider environmental impacts. And this is where science, technology, and engineering is so important, because it is through technology and engineering that we will deliver these solutions. Cities, of course, are hubs of innovation and creativity. And the technology is being used increasingly to change the way we live, with communication and digital connectivity, making work and leisure interactive online. Smart cities, where technology is leveraged to improve the lives of urban citizens, provide services more effectively. They reduce traffic congestion and accidents, optimize energy and water services, adapt for climate change, address pollution, and improve health and safety. Sharing knowledge on smart technologies for cities will build capacity and accelerate the transformation that we're looking for sustainable development. So what is geospatial information and how can it be used? We've seen some examples already by previous speakers. So geospatial information reflects the physical world. It takes data on the physical world and transforms it into a digital format. It basically is a digital library for a city and for a nation. This information is presented in many forms and media, including maps, satellite imagery, and aerial photography. And geospatial information for cities in particular draws on data like land administration and property ownership data, urban planning and land use, transport networks and hubs, health infrastructure such as hospitals, education, utilities such as water networks, nature reserves, natural disaster prone areas, and so on. And this data from a variety of sources is drawn together to drive social and economic policies for transport, energy, environmental management, waste management, and so on. So I will quickly present 3 case studies from the report which use geospatial information in various ways. The first is flood mitigation and modeling for Lisbon, Portugal. And here you see a geospatial map of central Lisbon with the Avenue de Liberdade running down the spine. And this information has been based on real-time sensors, video surveillance, public reporting, and a variety of other data, including the mapping of the city's water and stormwater networks. And it has resulted in huge improvements in the capacity of the system, reduction in flooding, and improvements in emergency response. The second case study I have is the digital twin for the city of Sydney, where I live. And the link I have shown is live data that you can access at any time. And this digital twin will be used for planning the growing city, especially to the west, using real-time transport data, data on utilities, broadband, building information, property data, information on trees and buildings. And finally, here I have a map on health data such as that used for COVID tracking and mapping. And again, the link is to live data, which again enables policymakers to use data from information such as credit card transactions and mobile phone locations to map the spread of the virus and to determine policies. So here it is. Geospatial technology is essential for smart cities, for buildings and infrastructure, and essential for sustainable development, for a better life for people, for better economy, for better services in those cities, for responsible consumption and action against climate change, and for developing institutions, especially in local government and in partnership. So geospatial technology is an important enabler, enabling the lever of science and technology to accelerate sustainable development. Thank you very much. You're muted. Can't hear you.
Dr. Gong, you are muted.
Thank you, Marlene, for your very comprehensive speech. Talk about engineering, sustainable development, and geospatial data. Now let's move to Professor Huadong, who is a member of the 10 members group of the technology transformation, technology facilitation mechanism of UN. And he will share with us about big Earth data. Huadong, please.
Thank you, Chairman. Good morning, good noon, good evening, my colleagues and friends. So see my title. I think we have the two keywords. The first one is the big Earth data. The second one is urban and peri-urban. So talk something about big Earth data. What's the difference between geospatial data and the big Earth data? What I want to say, very similar, look like the brother. Well, here I want to show you the first slide about this, Counsellor's program. So what Counsellor's? So several years ago, Chinese academic science launched a program. The title is the Big Earth Data, Science Engineering Program. So Big Earth Data, what I want to say, what's that? It's just based on observation, but not limited to the observation. So observation, we have remote sensing, we have the navigation data, we have GIS data, but bigger data, we also have like geography, geology, geochemistry, geophysical data, blah, blah, blah. So, recently, in the world, in China, we launched a lot of the satellite. So in China, we launched a meteorological satellite, environmental satellite, the land satellite and ocean satellite. Recent years, also we have a lot of the data with a high spectral, high spatial, resolution, the data. Just because we have so huge data, so what we should do, we should let the data become the information. Let the information become the knowledge, then support the decision making. So the program, we have the goal. The goal, just several later in Beijing, we should establish a new center. What's the title of the center? We call the International Science Center for Big Earth Data. Well, today, talk something about SDG 11 or urban sustainability. So big data can play a very important role for urban sustainability. Recently, we did some work. The Counselor's conducts about 21 practice case, for the urban and peri-urban development. We just focus on the 8 main things, including like urban public transportation, road network, open public space, heritage protection, urbanization, pollution, public health, and disaster prevention and mitigation. Well, here you can see the urban sprawl and urbanization. We did a lot of work about, by using bigger data for the global urban in previous service mapping in the past several years, both in China and in the world. So in China, we just using the 10-meter resolution, data that become the urban imperial service products. We acquired this data in 2015 and 2018. We compare with this, then we get some, result. And in the world, we did this work. You can see the, about the map, the different color. From the color, you can see we still facing, very big challenge. And you know that for sustainable development, we are facing the challenge. What's the challenge? First of all, we need science. We need the technology. So that's why United Nations just 5 years ago, launched the mechanism we call the Science Technology Innovation Mechanism. We can say is the TFM. So TFM, most important one, we need a different kind of the technology and the science. But here for urban monitoring, for urban sensing, and measuring something, we need some data. What's most important data? So here you can see about the, image show you, different kind of color. Actually, the yellow color means, it's urban and peri-urban area. What's for that? What we can do that? So in the past couple of years, we just used a very high resolution, synthetic aperture radar inside the data to get the imperials, the service map. So, along the Bahrain Road region, we use the inside system, the data in cooperation with the data monitor and measure, the SDG 1131 indicator. A total, we measure about 1,500 cities. These cities, at least the population is more than 300,000. And how long time? From 1992 to 2015. Every 5 years is intervals. So we compare with this result. This result released that, the ratio of the land consumption to population, growth rates increased from 1.24 in middle of 1990s to 2.67 in 2010 to 2015. And also we did some work about urban public transportation. Here you can see about the map is something about we producing the Chinese farm population grid data with 1 kilometer resolution. So show some different the sex and age for 2 years. The first is the 2015 and the second is the 2016, 18. The proportion of the population with convenience access to public transportation, compared with that, as the 2015 is about the 64%, and the 2018 is about the 80%.
Huadong, you have last minutes.
Okay, the last minute is about the cultural and the natural heritage. So along the Bahrain Road region, you can see the cultural and the natural heritage, what we use the bigger data to monitor about the heritage. And finally, I want to say already, we and write some report last year. You know, the title is Bigger Data in Supporting of SDG, already published for that. This year, a couple of months later, we will publish the new one that's 2020 years, the big data for SDG. So if you need this, please let me know that. Thank you very much.
Thank you, Huadong, for your comprehensive speech talking about the application of big Earth data. Now let's invite Professor Raida Al-Alawi. She is the Director of Technology Development of BFG International. Raida, we'll listen to your comments. Raida.
Sorry. So hello everyone from around the world. It's a pleasure to be a discussant at this distinguished forum. My comment is really related to the published WGIC joint paper, white paper, and it is aligned with what has been previously in the previous presentations. The paper focuses on the use of geospatial and BIM for building resilient and sustainable communities across 3 SDG goals, Goal 9, Goal 11, and Goal 13. I like to build on this by adding goal number 5, which is achieve gender equality and empower all women and girls to be included and addressed. Just over the past decade, the advancement in digital technology have transformed the industries. Among these technologies is BIM, geospatial, and all the technologies associated with the 4th industrial revolution, such as IoT, cloud computing, big data analytics, AI, mixed reality, drones, and these are just among many others. This revolution demanded new skills to be developed. The advancement in digital technologies is growing at a very faster pace than the production of a skilled workforce that can deal with these technologies. Currently, BIM careers, while remaining male-dominated, are experiencing a massive shortage in available skilled workers, and the demand of a qualified BIM specialist and the demand for a qualified BIM specialist has exceeded the supply. To meet this challenge of a construction's skill gap, we need to attract and retain a more diverse workforce to maximize innovation, creativity, and competitiveness. Hence, the recruitment of women is no longer an option to have, it's becoming a necessity. In countries facing construction skill and labor shortages, increasing the number of women in the workforce would go some way to solving the problem. According to a study in the US, the percentage of women in construction have hovered somehow between 9% and 10% since 1996, and is currently at 9.9%. In developing countries, this percentage goes way below 10%. In this respect, women have a lot to offer for construction industry when recruited and trained. Cyber-physical systems technology transform how people interact with information and the physical world around them. BIM digitalization solutions for infrastructures change perception of the construction industry being too physically difficult for women to handle will no longer be valid. I'll just share a live example I am experiencing on how the 4th industrial revolution technologies have brought women into the industry. I am currently working in a manufacturing firm, which is a totally male-dominated workforce. Recently, the company embarked on a project that will deploy the 4th industrial revolution technologies into the manufacturing process. Today, half of the workforce involved in this project are women who spend a good amount of time at the shop floor while developing solutions to create digital twin that serve real-time serves as a real-time replica of what is physically happening on the factory floor. So to conclude, empowering women in BIM and geospatial technologies will accelerate the global gender equality and the achievement of SDG 5. Thank you very much.
Thank you. Let's go to José Vieira, the president-elect of WFEO. Make your comments. At last, but not least. Okay, please. You are muted. José, you are muted. Open your microphone. Okay. Yeah.
That's okay?
Yes.
Well, good afternoon, good evening, good morning for everybody. It's for me a very special occasion to be inside this side event webinar as discusser. First of all, I must congratulate the panelists of this webinar for the brilliant and very interesting presentations that we have heard and seen. Well, my role here as discusser will be just to highlight some of the issues presented in this webinar. And I choose 3 points for this. The first one is about the importance of new IT technology in helping and solving problems in urban environments arising from natural disasters. The second one is about capacity building, and the third one about how to leave no one behind these new technologies. So I'll put my slides here. I hope that you can see it. Okay?
Yeah.
So about the first point, natural disasters. So I took some of the reflections of our panelists. So how geospatial engineering, digital transformation and innovation can contribute in anticipating events and modeling solutions. So points like machine control and data modeling, which allow efficient reaction by anticipating events, rules and standards in construction of resilient infrastructures, and flood mapping, mitigation and response for smart urban planning. The second point about capacity building for effective dissemination of technologies and their applications in a real context. And I point these issues, so develop knowledge and train expert technicians with holistic knowledge, develop skills necessary to handle the technologies effectively, ensure that results are effectively disseminated by society, and in a global way, the society adopts practices that can be truly collaborative in a smart city environment. Well, we know, and also we have heard, learned now about the urbanization in the world, and the more recent projections from the United Nations DESA about the population in the world. We can see a very big increasing until the end of this century. And one of these increasing of population is more effective in cities. And you can see in this map, also from the same source, about the increasingly amount of mega cities, so cities with more than 10 million inhabitants, and also big cities. And you can see that this big increase is in the southern hemisphere, mainly in Africa Asia, and some parts of Latin America. But this is one big point for have more and more difficulties in handling the environmental, the urban environmentals in these very big areas in our planet. So what this means about the difficulty or the facility to have these new technologies be incorporated in this new scenario of urban development. I have here a report of the Royal Academy of Engineering about one very critical situation of one continent is Africa, and here you can see some points that can be extrapolated for other regions in this planet. So this report has some conclusions. I picked some of them, and that is in my slide, that there is a severe lack of engineering capacity in the sub-Saharan Africa, which there is variation between countries. It is evident that across the region, the engineering sector suffers from a shortage of skilled and experienced engineers. And the key causes of the low capacity include a lack of government investment in engineering skills development right along the pipeline, out-of-date curricula and teaching methods at universities resulting in graduates lacking required skills, insufficient or lack of knowledge transfer from foreign engineering firms, and brain drain of engineering talent to other sectors and other countries. So these are the main conclusions of this report that can be extrapolated to other regions in our planet. So, and concluding this big issue about the transfer of knowledge, transfer of technology, and to have no people left behind, I can summarize the issues that we have point out as a perspective of our federation linking to the fulfillment of the SDGs objectives. So a successful sustainable development agenda requires partnerships between governments, the private sector, and civil society. These inclusive partnerships built upon principles and values, a shared vision, and the shared goals that place people and the planet at the center are needed at global, regional, national, and the local level. So this is my comments, my questions that I give to you, coming from our brilliant and very interesting presentations we have heard before. Thank you very much.
Thank you very much for your, actually that's a conclusion remarks you have already made. So please allow me to skip the Q&A session because we are run out of time. So, but the participants has made good comments in the chat box, and do give some questions. We are going to answer these questions later, and you get the Q&A from our website. Today, we are going to close the webinar because the time is run out, with heartfelt thanks to all panelists for such a good presentation. I could not bear to interrupt you, for your speech is so good. And that is just the start of our work. Let's continue our work and work together. So please allow me to declare the end of this webinar with sincere thanks to all panelists, all participants, and all partners on this joint work. Thank you again. Wish you a good morning, evening, and a good day. Bye-bye. Bye-bye. Thank you. Thank you. Bye-bye.
Congratulations. Bye-bye.
Thanks.
Thank you.
Thanks.
Bye.
Thank you so much,
Bye-bye.
Raida.
Bye-bye.
Thank you. Bye-bye. Thank you, Huadong. Thank you, Greg.
Thanks, everyone. Thanks so much.
Thank you,
Great.
Sanjay. Thank you,
very much.
Councillor He. Thank you.
So congratulations. Thank you. Bye.
Yeah,
Bye-bye.
please support us continuously.
Yeah,
Thank you,
absolutely.
everyone.
Absolutely.
Bye.
Great presentation.
Bye-bye,
Thank you.
everybody.
Bye-bye. Bye-bye.